Hello. Now with this workshop, we're going to be looking at something different again. We're going to be looking at Beer's Law, which is one of my favorites. We're going to be using the Go Direct spectral photometer. I have my cuvettes with standards set up already. I have a new bit of software which is quite good. It's called Spectral Analysis by Vernier. We'll put all this together and we'll get rolling. First thing I'm going to do, I'm going to turn on my spectrophotometer. The blue light indicates that it's sending out a Bluetooth signal, so I'm going to Bluetooth it straight to the computer. Over here on the computer, we have this option for connecting a spectrophotometer. I've found one. I'm going to click Connect. Okay, now that it's found it, I'm going to click Done, and we're going to be doing Beer's Law. So I'll hit Beer's Law, and we'll let the lamp warm up. Now it is important to let the light on the inside of the spectrophotometer warm up. You will get much better results that way. So if you ever find that you're having difficulty getting a good baseline, this will probably be the reason why. Because it does take a little bit of time to warm up, using the magic of the video, we'll just speed this up a little bit. Okay, so we've gotten to the point where the lamp is warmed up. All we need to do now is finish the calibration. For today's Beer's Law, my blank is just going to be plain water. So I have that here. First thing I'm going to do is take a little bit of paper towel and give it a quick wipe on the edges. I want to make sure that it's all nice, clean and clear to get a good reading. I'm going to pop it in, making sure that the clear side lines up with the arrow. And then on the screen, I'm going to go Finish Calibration. Okay, so in this case, we are going to be using water for our blank. I don't always use water though, depending on what I'm going to use it with. So for example, if I was going to do a chlorophyll experiment, I would use alcohol instead of water. But for this one, I'm just going to be doing food coloring. This one's a great one to be able to do at home if you do have a colorimeter or something similar, because you can look at the amount of food dye that's inside of sports drinks. Later on, I'll actually attach some notes as to how to make your own colorimeter at home. Back on the screen, we have the instructions. I'm going to remove the blank cuvette from the spectrophotometer and put it to the side. The next thing I'm going to do is take one of my standard solutions and pop it in. You can see on this graph, as I popped it in, that we have this beautiful peak here of maximum absorbance. I'm going to select that wavelength, so 631 nanometers. For blue solutions, this works quite well. I'm now going to click Done, and I am good to go. I went initially with the darkest one, but now I'm going to step back and go to my lightest solution. Now I've done a serial dilution with these. Pretty much it's 1 molar, 1.5 to 2.5. I'm going to hit Collect. Now the first thing I want to do is keep an eye on the absorbance down here. I want it stabilized, it's nice and stable. I'm going to go Keep, and I'm going to tell it the concentration. In this case, as I said, it was 1. In my data table, we have 1 and the absorbance. There is a dot on the graph, just over here on the corner. These will get a bit more obvious when we continue on. So I'll take that out, pop in my second one. Again, I'm going to wait for the absorbance to stop moving and go Keep. So as I said, it was 1.5. I'm going to keep that point. A nice little interesting thing with spectral analysis is you can also see the absorbance peak over here grow as we do higher and higher concentrations. So I'm going to place in my third one. This one was 2, waiting for it to stabilize. It has. I'm going to go Keep. Okay, and the final one is my 2.5. Again, Keep. So 2.5. This is the first step of the Beer's Law experiment. Now, if I was going to be doing field trips and say looking at nitrates in water, I may want to set up this calibrated curve at school. So in the field, I only need to do one small sample and I can line it up. We'll go back to the screen and look at the next step of how to analyze this. So now that I have all of this set up, I'm going to go stop. I'm going to come down and I'm going to make a linear curve fit. Apply curve fit, linear. This will line up all my dots. Now here I have this R value. The closest to 1 wins. So right now I have 0.9987, which for me is excellent to get it all lined up like that. Next step, I'm going to take my unknown value. My unknown value has been sitting there. It looks fairly light, but without a colorimeter or a spectrophotometer in Beer's Law, I don't know quite where it lies on the curve. So I'll give it a wipe, I'll pop it in. Back on the screen, the absorbance has stabilized at 2.06. Now I know that's somewhere around here, but to get this better, I'm going to go again to my tools and turn on Interpolate. This allows me to click on the line and to move this dot. I want this dot to equal 2.07, or as close as I can get to it. 2.06. It's kind of pop between 6 and 7. If I want to know the concentration, I now have it down here, 1.26 moles per liter. Beer's Law experiments are incredibly powerful and can be used in a whole lot of purposes. If I'm doing a field trip, the easiest way to measure nitrates, phosphates, calcium in the water is to use a testing kit which allows me to set up different concentrations. Back at the lab, I can set up my Beer's Law curve, so that straight linear fit, and then in the field, I just need to do that one cuvette, pop it in, and get a reading. That's if I don't want to bring it back to the lab as well. If you do have any queries, please feel free to contact me on the following email address.